This is EL6303, the question 2 of homework 2. I'm Hao Tian Liu. In this video, I'm gonna show you how do I solve the question, but I'm not 100 sure about this. So I guess this is the best I can do. So in this question, there's a signal goes through a serial noise channel. So continuously. So K means the K's noisy channel, and so these two are right here. X1 and X1 equals 1 and X1 equals 1 means the initial signal is 1 or 0, and the probability are 0.2 and 0.8 respectively. And this four equation means like this one means the signal, the k plus 1 signal is 0, given that the k signal means this signal goes through the k's noise channel. So the previous signal is 0, so the whole probability is 0.6. And so the first question asked about the probability of x2 equals 1, and so this one is pretty simple because we use the conditional probability, and we can use x2 equals 1 means two situations here. So first one is the previous signal, which is x1 equals 0. Another one is x1 equals to 1. So so we use the signal, we use the a conditional probability here. So we got 0.4 times 0.2 plus 0.7 times 0.8. So the probability of x2 equals 1 is 0.64. So let's try to verify this with another idea, which is the system transfer function. So as we know that the signal goes through a number of a system continuously, but there's no difference between among all the system. There's they have only one condition in common, which is the previous one in the previous signal, and the let's see, the output signal and input signal, the probability, they are all the same. So we can the only thing is the initial signal, the probability of initial signal is not sure. So we can write it in the matrix form. So this is x2 equals 1 and x2 equals 0 and x2 equals 1, the two probability, and this one is initial probability. So this one is the system. We use the matrix to describe the system, which means in the two situations go through the system, the whole probability, what is like. So this number here is exactly this 4 out here. So the outcome is 0.36, 0.64, and which is exactly, we use the conditional probability here, so it's identical. And in the next question, it asks about the probability of x3 equals 1. So we use the same idea here. So we're writing the matrix, and we're doing like this. Px3 equals 0, px3 equals to 1, and so it goes through. This is the initial signal, and this goes to the through to the two system. It's actually the noise channel in the question, but we can consider it as a two same system. So we use the square here, and the product here is 0.408 and 0.592. So the result of the second question is which is which is probability of x3 equals 1 is 0.592. And the next question is, it asks about the probability of x1 equals to 0 given that x3 equals to 1. So we use we know that this probability equals to probability of x1 equals to 0 and x3 equals 1 over probability of x3 equal to 1, and we can rewrite it into this form. And this one is exactly we use the same idea here. So the final result is 0.176, and I use so we can talk the last question and this question together, and I use a as capital A as to denote the system. So we can note that in this row means the input signal is 0. In this row, the input signal is 1, and this column means the output signal is 0, and this column means the output signal is 1. So so we can see right here means the initial signal here is x1 equals to 0, and this one goes to x3 equals to 1. So we can try to, when we square the system, and we should use x3, so that means the output signal is 1. So we use this one. And of course we need to use the x1 initial signal is 1, so we use this part in the square part, so we get the final result. And as we know that all the case system are actually all the same, and so we use when n goes to infinity, we already know that it asks about the nth, the final outcome of n equals to 0. So no, there's a bit of mistake here. Sorry for that. This should be 1. Yeah, we write it in the matrix form, and I think this will be better to show. So I use this transpose here. So I put the system matrix here, and this is initial signal. I just changed the direction, and I'm not sure how to compute this matrix to the end. So I use MATLAB. So if you know how to do this, please do reply me under the video. And so the final outcome is 3/7 and 4/7. So the final this question is probability of x infinity equals to 0, so it's 3/7. Okay, thank you.